Beneath our feet lies a restless giant. Earth, a swirling sphere of molten rock, conceals a blazing iron core. So hot, it rivals the surface of the sun. Trapped within this planet is a staggering amount of energy, leftovers from its violent formation and the constant decay of radioactive elements. This intense heat has only one path: upward. Massive currents of molten rock, thousands of kilometers wide, rise slowly toward the surface. Earth's crust, the thin outer shell we live on, is the only thing holding them back. It may seem solid, but it's as fragile as the skin of an apple wrapped around a cosmic furnace. Sometimes, this internal fury breaks through in catastrophic events that can rival or exceed the power of every nuclear bomb ever created. These rare but devastating outbursts reshape the planet, darken the skies, and plunge the world into chaos. These are supervolcanoes, but just how powerful can they become? And could one truly end life as we know it? Volcanoes come in many forms: towering mountains, bubbling lava domes, or gaping craters. But their birthplaces usually trace back to two key sources. The first is the boundary between Earth's tectonic plates. These plates, enormous slabs of crust, float across the planet's surface like pieces of a jigsaw puzzle. They grind against each other at a rate of up to 15 centimeters per year. It may seem slow, but over millions of years, it's a relentless battle. One plate often dives beneath another in a process called subduction. The losing plate is pushed deep into the Earth's mantle, into the asthenosphere, where temperatures soar beyond 1,300 degrees Celsius. Here, intense pressure keeps even melted rock in a near-solid state. But something else happens too. These subducted plates often carry water with them, water absorbed over thousands of years. When the heat meets this water, it sparks chemical reactions that melt tiny pockets of rock into magma. Because magma is less dense, it rises like bubbles in boiling water, collecting in chambers beneath the crust. Eventually, the pressure becomes too much and the magma bursts through. A volcano is born, a violent farewell gift from the plate being swallowed into oblivion. The second volcanic source is more mysterious: mantle plumes. These are vertical columns of superheated rock that rise from the boundary between Earth's core and mantle. Scientists still don't fully understand them, but imagine them as Earth's internal weather systems. Slow-motion rock storms, forming over hundreds of millions of years. Unlike tectonic activity, mantle plumes ignore boundaries. They punch through the crust wherever they please, creating islands and volcanoes in the middle of tectonic plates. Hawaii is one such example, a chain of volcanic islands drifting across a deep, fixed hotspot of Earth's wrath. These hotspots can stay active even as the crust above drifts away, continuing to spew lava for eons. To make sense of volcanic power, scientists created a dramatic scale, the Volcanic Explosivity Index, or VEI. It's a logarithmic scale, meaning each level is 10 times more powerful than the last. A VEI 2 might seem small, but it can fill 400 Olympic swimming pools with lava. Earth sees about 10 of these each year. A VEI 3 eruptions, like Indonesia's Semeru in 2021, can devastate local communities and displace thousands. A VEI 5, like the 2022 Hunga Tonga eruption, blasts cubic kilometers of material into the sky, sending shockwaves around the globe and triggering ocean-wide tsunamis. Now it gets dangerous. At VEI 6, eruptions can alter the global climate. In 1883, Krakatoa erupted with fury. The island tore itself apart, creating the loudest sound in recorded history, heard nearly 5,000 kilometers away. Waves 30 meters tall destroyed coastlines. Ash and gas blanketed the atmosphere, cooling the Earth by half a degree Celsius. Blood-red sunsets followed for years. Then comes VEI 7 supercolossal eruptions. In 1815, Mount Tambora exploded with a force 400 times greater than the largest human-made bomb. It blasted 140 billion tons of ash into the sky and turned global skies a sickly yellow. The world's climate plummeted. Crops failed. Famine swept across continents. 1816 became known as the year without a summer. Supervolcano isn't a formal scientific term. It's a label coined by the media. Not every eruption from a supervolcano is truly cataclysmic. What defines these beasts is time and scale. For hundreds of thousands of years, pressure builds beneath the surface, hidden inside massive magma reservoirs stretching for miles. Eventually, pressure lifts the ground, cracking the rock above until, boom, a super eruption rips through. We're talking about eruptions ejecting over 1,000 cubic kilometers of ash and lava, enough to affect every corner of the planet. But what follows is perhaps even more haunting. The ground collapses into the emptied chamber, creating a vast caldera, a sunken scar in the earth. And so the cycle begins again, quietly building pressure for the next explosion, which may be hundreds of thousands of years away. The most recent super eruption, the Oruanui eruption in New Zealand 26,500 years ago. It unleashed the power of tens of billions of tons of TNT, blasting out enough material to reshape the southern hemisphere's climate. But this was small compared to what came before. The Lake Toba eruption 74,000 years ago was a planetary turning point. It expelled 5,300 cubic kilometers of ash, burying parts of South Asia and causing a temperature drop of up to 4 degrees Celsius. The resulting volcanic winter may have lasted a decade, followed by droughts and failed ecosystems for centuries. Humanity itself may have nearly gone extinct. And then, far back in time, came the Siberian traps, a different kind of monster. Around 250 million years ago, lava poured non-stop for 2 million years. Ocean temperatures soared past 40 degrees Celsius, triggering the Permian-Triassic extinction, wiping out over 90% of all life. Earth needed 9 million years to heal. These weren't eruptions. They were world resets. So, should we live in fear of supervolcanoes? In short, no. While they are terrifying in theory, they are also extremely rare. The infamous Yellowstone volcano, for example, will erupt again, but likely not in our lifetimes, and not in a way that ends civilization. When it does erupt, it will probably be a smaller, localized event. The odds of a VEI-8 eruption in the next few centuries are less than 2%. And crucially, it wouldn't be a sudden surprise. Modern science can detect swelling magma chambers, shifting ground, and temperature spikes, offering enough warning to evacuate. But lower magnitude eruptions? They are far more common and still dangerous. To stay safe, humanity must continue monitoring volcanic activity, measuring ground deformation, checking for gas leaks, and tracking heat signatures. These early warnings could save millions of lives. Beyond that, science may offer bold solutions, technologies that could scrub sulfur and ash from the stratosphere, or even harness the geothermal energy stored beneath calderas to fuel our future. And if we can redirect asteroids, as we've recently done, then surely we can defend ourselves against threats that rise from below. Earth's core may rumble and churn, but that doesn't mean we're helpless. Humanity has always adapted, always found a way. So yes, the beast sleeps beneath us. But tonight you can rest easy.